section's on 7.3 volume. So the volume is a little tricky because it just depends on which axis that you rotate around. You're going to have a different equation. And also you have to know is that the volume is equal to the integration of area. So vice versa, if you take the derivative of volume, then you're also going to find is the area. So we can work backwards as well. Okay, so let's take this and we're going to revolve the first thing around the x-axis. So if I take this object right here, which is that triangle shape, and we're spinning against the x-axis right here, right? There is no gap along this object and the x-axis that we're spinning against. So when we spin it around, the 3D shape of this is going to be a cone. So when I cut it perpendicular to the x-axis that we spin it around and open it up, it's going to be a circle. So then we want to set this up as a circle formula. So then volume is equal to pi r squared, right? Because that's the area of a circle. So now we need to figure out is what is r. So r is going to give us this right here. So it's going back to that 7.2 when we found the area. This is your top minus the bottom part of it. So your top equation is the y equals 3x, and then the bottom equation is going to be y equals 0. So just for some people's sake, I'm just going to go ahead and put that, the 3x minus 0, because it's that top minus the bottom part of it, and that's your dx. So now because I have x's in the equation, I have to figure out is what is my x. So x is equal to from 0 to 2 in this case. So our limits are from 0 to 2 right there. Okay, so let's simplify that a little further. So then I have from 0 to 2, and I'm going to get rid of that 0 right there. So then we're going to have is just then 3x squared, actually 9x squared, right? Because then 3 times 3 is 9, and then the x squared right here, dx. Okay, now we're ready to do the integration. So that gives us then 9x cubed over 3, right, from 0 to 2. And then from there, that simplifies to 3, right? So then we're going to get is equal to pi 3, 2 cubed, and that's 8, right? 8 times 3 is 24. So we're going to get 24 pi. Now you can actually calculate that pi into that 24. It's optional to calculate it. Usually on the multiple choice for the AP test, it's not calculated. On the open-ended question, it's optional to calculate or not. It's not wrong or right to calculate it. So just for sake of time, I wouldn't even bother calculating it. I would just leave it as 24 pi on this one right here. Okay, now let's take it to revolving it around the y-axis. Now, if I take the same object right here and I revolve it around this y-axis right here, it's going this direction. So let's just do like a little imaginary line right here. And this would be the opposite of the y equals 3x. So this is like y equals negative 3x instead. And if I spin it around the y-axis, I'm going to kind of get like a circular ring to this right here. Something like this. And so this is the object that if I spin it around, it's same thing. I'm going to get on this side right here, right? It's going to be another shaded area kind of like this right here. And so then you're going to get is a hole in between right here. So we call that the washer. Remember, we have is the washer. So washer looks something like this. The big R is going to be from the center to all of this right here. That's your big R right there. And then the little r is going to be the little hole right there that we're going to try to get rid of right there. So we're doing the same thing for this one. We're going to get the area of all of this right there, and then we're going to take away is this right here, the hole right there. So in this case, our washer formula is going to be volume is equal to pi big R squared minus the little r squared dr. Okay, so the big R. So the big R in this case is kind of like you're finding the volume or area of all of this right here. So still that right minus left idea. So the right is going to be x equals 2 minus x equals 0 right there. So the distance of that is all of this is 2 right there. So that's my big R. So that's going to be 2 squared minus, and then my little r. So the little r is this gap right here, the hole that we have right there. So it's going to be this right here minus this. Now, here's the tricky part. If I'm spinning it against this direction, this way, then I need an x equals because I'm spinning it against the x technically it's like the x-axis right here, because if I go like x equals 2 right here, right, it's vertical. So if I spin around vertically, it's x equals. If I spin it around horizontally, you're going to get y equals equation. So since I'm spinning it against the y-axis right here, which is vertical right here, we're going to have to change this equation right there to an x equals. So this becomes x equals, if I divide by 3 on both sides, we're going to get y over 3 on this right here. Okay, so this is then becomes x equals y over 3 minus the 0 right there. So that's what this part right here is, y over 3 minus the 0. I'm not going to even bother to put the 0, but that's what that is. It's your right minus the left still. And so since this is y, we got dy in there. So again, we have y in the variable, so I need y as my limits. So the limits are going to become from 0 to 6 on this one. So from 0 to 6, okay? So we have to do some simplifying right there. So pi 0 to 6, let's see, that gives me 4 minus y squared over 9, right, dy. So if I take the integration of that, it becomes 4y minus y to the third over 27. And then we still have from 0 to 6, and we still have that pi involved, right? We can't forget that pi. And so when we calculate that out, I believe for this sake of time, I'm just going to call it 16 pi. I think you could just substitute 6 in yourself and figure that out. So that's going to give us 16 pi right there. Okay? So now we go on to part C, which is now revolving against y equals 6. So if we take this line right here, and we call this y equals 6 right here, and we just extend that out to y equals 6. And we're going to still take this triangle shape right here, and we're going to spin it around y equals 6 instead. Now, when we spin it around y equals 6, we still have is that gap in between right here. So since I have a gap, this is a washer formula. So right away, I can just set it up as a washer formula. So volume is equal to the washer formula, which is the big R squared minus the little r squared dr, right? Now we got to figure out is the big R and the little r. So same idea right here. My big R is going to be all of this area right here that I'm trying to figure out. So the height of this is 6, so it's like top minus the bottom. So 6 minus 0, that's 6 right here. So all of this right here, I'm trying to figure out the area. So that's the big R. So that's going to give us 6 squared minus, and then little r. So again, that top minus the bottom. So 6 minus this right here is going to give us the gap right there. So in our case, the gap, we're revolving it around this way horizontally. So I need a y equals. So we're going to go with the 3x right there. So we're going to go 6 minus the 3x right there squared, right, because that's my little r. And then dx right there because I have variables of x. So since I have variables of x, then we need is from 0 to 2 on the limits. So from 0 to 2. Okay, so now we just need to simplify this before we take the integration. So this gives us what, 36 minus, I think this comes out to 36, let me put parentheses on that one, minus, and if you distribute this out or FOIL it right there, I believe it comes out to like 36x, and then plus 9x squared. So do the math on that one just to check to see that foiling, if that's correct. That comes out to something like that. So I think the 36 should cancel out because that's a positive and that's a negative. So then we get pi, 0 to 2, and then we get, distribute the negative right there. So that's positive 36x, and then minus 9x squared dx right there. And if we take the integration of this, it becomes pi 36x squared over 2, right, minus 9x cubed over 3, and then from 0 to 2. So again, if you do the calculations of all of that, I believe it comes out to 48 pi. So check the work on that one, and I believe it comes out to 48 pi right there, okay? So that's, again, revolving around y equals 6 on this one. Now let's take it one more step and then revolve this around x equals 2 instead. So we take this object and we're revolving it around here. So we're taking this triangle shape and we spin it this direction. If we spin it this direction right here, there is no gap between the x-axis. If I spin it around, let's say x equals 3 right here, or 4, something else, then there's going to be a gap between that and then the axis that you spin. So in that case, that will be a washer again because it's creating a hole right there. But since we're spinning around x equals 2, there is no hole, so that's going to be back to that circle formula. So a lot of these are going to be either circle or going to be a washer formula. So it's going to be pi, and the circle was r squared dr. So equals pi, and then the r. So r again is going to be, we're going to go with the area right here. So it's going to be then the right minus the left, but since we're spinning around this direction, right, we mentioned how we need x equals, so we're going to have to use that x equals equation right there. And so your right minus the left, the right is 2, so that becomes x equals 2 minus, and then the equation becomes y over 3, so y over 3 squared, because that's your r, all of that. And so dy, so from 0 to 6 again, right, because the limits are from 6, okay? So I believe we have to distribute that out or FOIL it. So we have from 0 to 6, let's see, that comes out to be something like 4 minus, what's the next part? Let me see. 4y over 3 on that one, and then plus y squared over, I think, 9. If you FOIL all of that out, dy, right? Yeah, we'll have to stick the little dy in there. Okay, so then we do the integration of that, so then that becomes 4y minus 4y squared over 6, right? Because it's the denominator, plus y to the third over 3, so that's 27, and then from 0 to 6. And again, if you substitute 6 in, you don't have to do the 0, just substitute the 6 in and do the calculation for that, and I believe that comes out to 8 pi right there. Okay, volume right there. So again, check that work on that one. I believe if you FOIL this out, it comes out to 4 right there, because in the middle term, that's going to give us a 4y over 3, and then the last term, I believe, gives us y squared over 9. Okay, so again, it depends on this right here, the rotation. If we rotate around this direction, it's going to be y equals because it's horizontal. If you rotate it this direction, it's going to be x equals because it's vertical. So just work on that one. And make sure when you find the area, it's either, if you rotate this way, normally it's going to be your right minus the left because it's all against from here to against the axis that you rotate around. If you spin it around horizontally this direction, then it's going to be your top minus the bottom for finding area that we just did in 7.2. Okay? All right, now go ahead and try the classwork problems.